Have you ever wondered how to write a SQL query in Redis? Or how to index your data like you index tables in a relational database? What about creating reports with aggregates like sum and average? These are all common tasks in relational databases, but in Redis, they've been less straightforward. That's all changed with the release of RediSearch 2.0. The source available RediSearch module gets you a lot of the query and aggregation features you've been missing in Redis. And in this video, I'm going to show you how to use these features in your own applications. You'll want to stick around for this. RediSearch is a source available Redis module, and it's been mostly thought of as a tool for full text search. But with the recent 2.0 release, RediSearch became a lot more powerful and general purpose. You can think of it as the missing query and indexing engine for Redis. So let's get started. I want to talk about how indexing and querying work in traditional databases, and then we'll see how they work in RediSearch. But first, a quick review of the Redis data model. Typically, a Redis database contains many different keys, and the key names create a namespace. Take user data as an example. One way we can model a user in Redis is to have a hash for each user. Each hash is accessed with a key, like users::profile::user ID. Inside the hash, we store the user's first and last name, their username, registration date, and so on. Keys in a Redis database are like primary keys in a relational database. With our user example, you start with a user ID and then construct a key, and then you can use that key to request the data you want from Redis. That request is a constant time operation. In other words, it's fast, often faster than a primary key lookup in a relational database. But what if you want to query on attributes other than the primary key? Say you want to look up users by last name or registration date or country of residence. In that case, you need a secondary index. To understand querying and secondary indexing in Redis, let's compare and contrast the way we store and query a simple user model in Redis with the way that we do that in a relational database like Postgres. In Redis, I'm storing my users in hashes with the fields you see here on screen. First name, last name, bio, registered on, and country code. I can now add a user by issuing this hset command. In Postgres, I'll create a table with a definition that mirrors the hash structure you just saw. In this create table statement, I've defined first name, last name, and so on. Now, I can insert users using a typical insert statement. Once we've populated Redis and Postgres with data, how do we index and query this data? In Postgres, I can query the table using SQL. But if I want those queries to be efficient, I'll probably also want to add some indexes, like you see here. In Redis, I need to create a RediSearch index on my data before I can query it. Here's what that looks like. This index applies to hashes whose keys match the given prefix, users::profile::, and I've specified that I only want to index the first name, last name, bio, registered on, and country code fields from the hash. Now I'm ready to perform efficient queries for the same data in both databases. Let's look at a few examples. First, let's search for users by last name. In SQL, you do that like this. And with RediSearch, the query looks like this. Next, let's add the country code field to the query. Say we only want users with the last name Brookins who live in the UK. First, SQL. Now, RediSearch. How about we throw some Boolean logic into the query? We'll find users with the last name Brookins who live in either the United Kingdom or France. First, SQL. Now here's the equivalent query in RediSearch. Next, let's look at querying dates. First, here's how you'd find users who register on a specific date in SQL. And now, with RediSearch. With RediSearch, you express dates as Unix timestamps. So a date like January 1st, 2021 is the timestamp 160-945-9200. Querying by date requires you to give RediSearch the timestamps that represent the upper and lower bounds of the date. That's what we've done here. How about searching for users who registered between January 1st and February 1st of 2021? First, SQL. Now, RediSearch. Like before, we represent dates as numeric timestamps. This time, we use a range that starts on January 1st, 2021 and ends on February 1st, 2021. Some of these queries might return thousands of results, so we should paginate them. To paginate in SQL, we use an order by clause with a limit and offset. In RediSearch, we specify sort by plus the field we want to sort by, and we provide an offset and limit as arguments to the limit keyword. You can see that RediSearch lets you sort and paginate, similar to what you get with SQL. Sure, the RediSearch query language isn't as fully featured as SQL. For instance, you can't do joins. On the other hand, RediSearch gives you the power to build dynamic queries a lot like you can with basic SQL. Of course, you can also do full text search and aggregations. Let's look at those use cases next. RediSearch is a powerful indexing and dynamic query engine for Redis. But as the name implies, it's also a search engine. You get robust search features on par with other dedicated search engines, and your searches are extremely fast because the entire search index is stored in memory. This makes RediSearch great for applications that can fit their indexes in memory. It's also useful for cases where you need to create and destroy a lot of indexes frequently, which we call ephemeral indexing. But because the data is stored in memory, RediSearch probably isn't the right fit if you measure your search index in petabytes. So how do you use full text search with RediSearch? First, you'll want to have some text fields in your index. The user index we talked about earlier should work. Here it is again as a refresher. Notice that we've indexed the bio field as a text field. Let's write a full text search query using this index. Say your app is a professional networking site, and you want to find all users whose bio contains the terms data engineer. In RediSearch, the query might look like this. This query does a full text search for users whose bio includes the terms data and engineer. Full text searches use a technique called stemming to find matches on related terms. Let's consider an example of how stemming works. With our professional networking site example, maybe you're looking for a data engineering manager. So you look up the terms manage data engineer, and RediSearch finds a user whose bio includes the text, I've been managing a team of data engineers for the past 5 years. You can also control the scoring algorithm that RediSearch uses. By default, it scores documents with the form of TF-IDF, but it includes several other scoring algorithms, and you can build your own with the extensions API. You can also weight results through a special score field in your hashes, or by assigning weights to subclauses of a query. A lot more search operators are available too. Queries can use multiple clauses, and these clauses can include things like numeric ranges and geofilters. Anyone who's worked with data has probably created a report before. With traditional databases, these reports use aggregation commands like count and sum. RediSearch gives you the tools to build these reports with Redis. As an example, say you need to write a report breaking down the total number of users who signed up per day for the last 30 days. For simplicity's sake, we'll ignore days that have 0 signups. In SQL, you could write something like this. This query gets all users who registered in the last 30 days, groups them by registration date, and then counts the number of users who registered on each date. With RediSearch, you can build an equivalent query by using aggregations. Take a look at this RediSearch query. This query selects users registered 30 days before January 1st, 2021, which is December 2nd, 2020. We need to calculate that date and include it in the query as a Unix timestamp. The query then groups registrations by date and counts the number of hits per date. It's worth noting that in addition to building reporting queries, you can use aggregations to create real-time faceted search experiences. If you aren't familiar with this term, faceted search is the kind of search experience you get on most e-commerce sites. You do a full text search and the results page allows you to refine your query by category. So you can see that aggregations are an essential feature that you can use to build the same kinds of reporting queries that you can with traditional databases. At the same time, they can power faceted search if you're building a search experience. RediSearch is the missing query and indexing system for Redis. If you store structured data in Redis, you should really install RediSearch. Doing so lets you run SQL-like queries. You also get the kinds of aggregations you need to build reports and a robust full-text search engine. If you want to get hands-on, you can try RediSearch with the official Docker image. Read more about how it works in our documentation, where we have a quick start tutorial.